So the same way we have methods of differentiation is the same way we have methods of integration. Okay. So as we do question 5, we'll be able to discuss several methods of a differentiation. That is one, I can do a summary of them. We have one, extended power rule. That means that if I'm integrating x to the power n dx, my integral is going to be x n plus 1 over n plus 1 plus a constant c. Now this method can be used to answer question 5a. As an example, integrate 3x squared plus 2x plus 1 dx. The solution here is going to be 3x 2 plus 1 over 2 plus 1 plus 2x 1 plus 1 over 1 plus 1 plus 1x 0 plus 1 over 0 plus 1 plus a constant c. So I've deliberately shown the 0 there because we know that x to the power 0 is 1. So when there was just 1 there, it means that x was present but to the power 0. So this becomes 3 over 3. So we just have x to the power 3 plus 2 over 2. So we just have x squared plus x plus a constant c. If you differentiate this, you understand that you get the integral inside. You get the question under the integral. So if you are doing a study alone and you're wondering whether the integral solution is correct, you just differentiate what you've gotten. If it gives you the question, then you know it's correct. And we call this the extended power rule. And so it looks like there's a continuation. We go to B, x to the power 5 over 2 minus 5 over x power 4 minus root x dx. So how do you integrate this? I say, okay, I will use extended power rule. I'm going to have x 5 over 2 plus 1 over 5 over 2 plus 1 minus 5x negative 4 plus 1 over negative 4 plus 1 minus x half plus 1 over half plus 1 plus a constant c. The reason why we are putting a constant c there is we understand that the integral, the derivative of any constant is 0. So it won't affect the solution. But if you leave it, then your solution is wrong. And how does the 4 become negative? Okay, so I understand.
What's the question, sir?
It becomes a negative as you are removing it from the denominator.
Wonderful. Okay, so we add 5 will give us 7/2 there. So we'll have 2/7 x to the power 7/2 minus, now it is going to be plus 5/3 x to the power -3 minus x 3/2 and 2/3 plus c. And we need to leave the x where we found it in the denominator. So this becomes our solution. Any questions? Any questions, guys? No questions. Okay. What is on C? The integral of 2x root x minus 1/√x dx.
All right, thanks.
So this is the same as the integral of 2x x to the power half minus x to the power -half dx. So if we multiply, we'll get x, 1 plus half, we get 3/2, and then minus x, -1/2 dx. Then we integrate. So we have 2x, 3/2 plus 1 over 3/2 plus 1 minus x, -half plus 1 over -half plus 1 plus c. So we get 2x 5/2 over 5/2 minus x half over half plus a constant c. We can write this as 4/5
Is
x.
it positive or negative?
The half down is positive. So I can write this in this form. The power 5 minus.
How does it become 4/5?
X plus c. So we have 2/5/2. So the 2 on top, we can write this as that. Change it to multiplication, which is 4/5. Is it okay?
Yes, sir. Yes.
Okay. That's how the solution comes out. 4.
So, there on the last solution, if you were not to replace the 5/2 the power x, the way you've written it, the final answer there, then you left it in the form it is in the second part. Would it be wrong?
It still be correct. For as long as
Right,
you rearrange your for as long as the constants, the coefficients are okay, you can write the powers in any way.
All right, thank you.
Okay. What's the next thing now? The next thing is D. Three x now plus 4 squared over root x dx. So this is the same as the integral of 9x squared plus 24x plus 16 over root x dx. You expand the numerator, and that's how we expand. And then we write this as 9x squared over root x dx. If we want, plus 24x root x dx plus 16 1 over root x dx. So here I'm just bring up a property that says that you can separate the pieces of your function and then integrate each piece at a time. Now here you can write the constant can be taken out, and then we'll have x squared multiplied by x to the power negative half dx. We have 24x x to the power negative half dx plus 16 x to the power negative half dx. You can still write this as x. We get 3 over 2 here dx plus 24x, we get half dx plus 16 x to the power negative 1 over 2 dx. Then we integrate. So we get 9x 3 over 2 plus 1 over 3 over 2 plus 1 plus 2x half plus 1 over half plus 1.
Sir, it
Plus,
was 24 at first. 24.
yeah, what happened?
42.
So it's still 25. All right, good. 24. And then 16x negative half plus 1 over negative half plus 1 plus c. So we get, when you add the when you add the denominator, it will give us 5 over 2, so that we get 18 over 5 x to the power 5 over 2 plus Here we'll get 3 over 2, but 3 can go in 24 8 times. So 8 times 2 will get 16 x to the power 3 over 2. Plus, this is half, so we'll have 32 x to the power half plus c as our solution. So yours is to be slow and add those numbers and see to it that for sure it is 16. Or maybe there's a question there. Are you able to see how these constants are coming about?
Yes, we are. But how did you find 24x on top there?
You mean this 24?
Yes, please.
This one you're just carrying it from here, from the question. Here, when we're expanding 3x plus 4, you get 3x times 3x, 9x squared. 3x times 4, 12. Again, 4 times 3x, 12. 4 times 4, 16. Then you add the 12x, 12x, you get 24. Then it keeps coming down until the last stage.
Sir, can you please repeat on the step before the final answer? I didn't get it how you got 16 there.
How we got 16 on the last piece?
Yes, sir.
So what we have is 24 over half plus 1. This means that we have 24 over 3 over 2. If reciprocate the denominator, it's going to be 24 multiplied by 2 over 3. But 3 can go here, 3 can go there 8 times. So 8 times 2 is 16.
Thank you, sir.
Okay. So this is, this method of integration is very, very important. As you saw that when you are differentiating, power rule is very, very important because it keeps featuring in all the other methods. If you have product rule, when you separate them, you use power rule. If you have quotient rule, when you separate them, you use power rule. You have chain rule, you use power rule. Implicit, you use power rule. So the same way power rule is used in every method, it's the same way extended power rule, it will be used in every integration method. So that's why you must take time and understand this. Okay. Then we go to, I think E is okay. We can easily do E and F. Let's go to G. G is the integral of 2x over t to the power 5 minus the root of tx plus 4x plus 4x dt. So our task here is to integrate with respect to t. So anything that is not t is regarded as a constant. This means that we can write 2x outside and have t to the power -5 dt minus the root of x outside and have t to the power half dt plus 4x dt, meaning that we have 2x t -5 plus 1 over -5 plus 1 minus root x t half plus 1 over half plus 1 plus 4x t plus a constant c. This means that we have 2 over -4, which is equal to -1 over 2 x t to the power -4 minus root x t to the power 3 over 2. And so this will be 2 over 3. And then plus 4xt plus c. You can choose to come back here and write this guy as 1 over, not necessarily 1, as x over 2t power 4 minus 2 over 3 root x t to the power 3 over 2 plus 4xt plus c. So the d variable tells us which variable we must integrate with respect to. Which variable is of our interest. The other things we don't care. We treat them as if they're just numbers. And then, so this was the extended power rule, and we're remaining with a few minutes, so we can log out and log back so that we do question 6. So let's do that quickly.